Okay, if you've made it this far in calculus, the fact you're actually taking calculus means you probably were pretty good at equations of lines back in the day whenever you come across them. In calculus, we're going to see them yet again. Because you know how when we introduced the definition of derivative, we talked about how was the slope of the tangent line to the graph? Well, guess what? Now they're going to want you to find the equation of that line that is tangent to the graph at a particular point. So, to that end, that'll be the next video. First, I just want to review with you the best form of lines for calculus. What I find is that most students prefer y equals mx plus b, which is fine and dandy, but it's not actually the easiest way to do a problem. If they give you a point and they give you the slope, it turns out that this is the easiest thing. It's called point slope because you can just plug in a point, x1 and y1, and plug in a slope, and you're done. You can just circle that and call it your answer. In calculus, usually if they want the equation of a line, they don't tell you what form to give it in. They don't tell you it has to be point slope or slope intercept or standard form or whatever. They just want the equation of the line, which means you can slap up the easiest thing to come up with that you can think of. So I'm just going to introduce a couple of examples just to remind you what point slope is, get in the habit of using it because it is the quickest and easiest way to do it. All right, so find a line, the equation of a line through the point 3 comma 5 with a slope of this. Check it out. That is a point and a slope, so I want to use point slope form. To remind you, what we do here is we write down y and then minus, but then y1 is what we replace with a y coordinate of the point we know. So y1 is just going to be 5. And the slope is 2. And then x minus, and then we plug in the x value of the point they gave us, 3. At that point, you are done. If you have to have slope-intercept form, y equals mx plus b, at this point, you can just go back, FOIL this out, multiply the 2 by the x and the negative 3, and then rearrange stuff. But there's a great starting point no matter which form you intend to give the answer in. And what's best is if they don't care and you just give them this answer and you're all done. So, in calculus, you're always going to have a point to work with pretty much, with a few exceptions. All right, so this one's slightly harder. Why is it harder? I'll give you a hint, it's not. It's just got a negative sign in front of this 2, which will, keep track of your negative signs, and the slope's a fraction. But with point slope, who cares? Y minus y1, which is just 4. Slope is negative 1/2. X minus the x coordinate. And this is the only thing that's tricky. Oh, look at that. We had a minus led to a plus. But other than that, check it out, man. We're done. And that's why I always tell people use point slope form. All right, so that was the slightly easiest ones where they actually give you the point and the slope. It's still going to be the easiest way to do these problems, but this time they just gave us 2 points. This is not the type of problem you come across very often in calculus. Usually you'll have the slope and the point, but this isn't so bad. We have a point, so we can just plug in either one of these points we want for x1 and x2. So I don't know, I like to use the one that has more positive numbers in it. So we got y minus 3 equals something times x minus 2. What is the slope? And they didn't give it to us, so we just got to calculate it using the points given. Let's do 1 point minus the other, so m equals the difference in y's, so 3 minus 0, over the difference in x's, same order, so 2 minus negative 1, gives you a positive 1, so we get m equals 3. That was convenient. Thought it might be a fraction. That was an accident. All right, that's all there is to it. Point slope form. Hopefully this shows you why, how wonderful it is, and I would encourage you to always use it. If you're a big fan of, slope intercept, well, good for you, but you're going to be slower if you're sitting there solving for b all the time instead of just plugging and chugging the point and the slope and moving on to the next problem. Calculus is a fast-moving test. You're hardly ever going to have enough time, so you want to do things the quickest way possible all the time.